All right, so welcome everyone to your Thursday evening dose of astronomy. I'm Irene Pease with the Amateur Astronomers Association in New York City, and we're happy to be exploring the universe with you tonight. So some of the programs that I'll be using, as usual, we have OpenSpace, which is what you see in the background right now. You can download it for free, fly around, explore the universe like we're going to, and even more than what we're going to see tonight. That's all free, open source software that you can get at openspaceproject.com, and we'll see more of that in a little bit. We're also going to be using Stellarium, which you can find at stellarium.org, and we're going to be starting off with a little bit of Stellarium. So tonight, I'm very excited, popping over to Stellarium here, looking at now. So tonight, the theme is what I call it, small steps, giant leaps. So kind of think what that's going to be about. And then, we'll talk about some small steps and some giant leaps. Some very exciting things for a lot of astronomers over the last couple weeks. I know my inbox and my email has been flooded with NEOWISE images and stories and just people out looking for it and trying to coordinate. So it is still up in the sky. It's a little bright. Again, this is the setting for New York City, specifically Brooklyn. It's going to be a little bit dimmer. I think if I click on, is that it? Yeah, that's it. So if we look at the magnitude, if you know magnitudes, that's how we kind of describe the brightness of something in the night sky. 4.3, that's going to be at or beyond what we can see from a New York City sky with all our light pollution. If I move to a little bit later, maybe not that late, just kind of 10 o'clock-ish. Still, 4.3. So you'll want to wait for it to get a little bit darker, and over the coming week and more, should be getting fainter. So you want to get yourself out to a dark sky. If you haven't had a chance to see it, highly recommend it. It's pretty gorgeous. I got to see it in all its glory last week from a really dark site. So it was really beautiful. Great tail and everything. Tails, plural. So if you're a AAA member, a member of the Amateur Astronomers Association, if you're in some of the special interest Google groups, you know all about this. If you're not, then join some of our groups and you can hear people's stories and see some of the amazing images from our astrophotographers. So enough gushing about NEOWISE. There's a whole other excitement. So much going on in the sky tonight and every night. So tonight we have the moon out. It's a very new moon. It's 3 and some odd days old. Here it's magnified a little bit. So if you are out just after the stream, you might catch kind of a crescent moon over there. And we'll take a look at that again. So as some of you might know, this last week was a 51st anniversary of the Apollo 11 moon landing. So all the moon landings that we had between 1969 and 1972 were kind of coming up on all those 50th anniversaries. So 50th anniversary for 11 was last year, and we're seeing more of them and will through the next couple of years. But that's kind of like the inspiration, if you haven't already figured it out, for tonight's theme, small steps and giant leaps. So for our challenge for this week, kind of keeping in with the theme, we're going to look a little bit later again, closer to 10 o'clock, and we're going to look at something we've seen before. So if you follow the Milky Way up way overhead, not that you can see it from New York City, so let me just make this a little bit more New York City. We'll just kind of crank up the light pollution. Okay, that's a little bit better. Yeah, that's more New York City. But the bright things that are overhead, if you recall, we have the summer triangles, so the 3 stars that make a big triangle in the summertime. So there's Vega and the constellation Lyra, which is a harp. There's Altair down here, and Aquila the eagle, and then Deneb, which is the tail of Cygnus the swan. So I think I've pointed out some things in Cygnus before. We looked at the Veil Nebula a couple weeks ago, big bangs and stuff. But this week I want you to look for this region in space kind of between Deneb and Vega. So that's your challenge, to find that part of space. If we just kind of turn on the lines here, the swan, remember the swan's kind of flying along here. So Alberio, really beautiful binary star, is its head, Deneb the tail, and then from this star along the central line, you go out to the third star on either side. So if you're going out to the third star westward, this region in here is something that we're going to be looking at in a little while in OpenSpace. So that's your challenge, is to find the space between Deneb and Vega. And I'll show you what's actually there if you had a ginormous telescope. But we'll go ahead and flick on over to OpenSpace. So OpenSpace, here we are, Earth, as usual. And yeah, we like to begin our journeys here because it's where it all kind of begins. So before the Apollos, right, before the whole space race got started, what kind of kicked that off way back in 57, for all y'all who were alive in 1957, that was the first time that we launched something into space. So the Soviet Union launched Sputnik out into space. It was, terrifying for Americans at the time, but really incredible. It was the first thing that this little space vessel, this little metallic basketball that orbited the Earth. So that was kind of exciting as far as, scientific progress goes. A few years later, they sent a man around the Earth. So Yuri Gagarin, the first person to orbit the Earth in a slightly larger metallic ball, slightly safer because he managed to get back safely in one piece, which is great. Live to tell about it and all that jazz. And then many years later, the whole decade after Sputnik, in 1969, is when we made that leap to the moon. So a lot of small steps along the way, but eventually we got out on this giant leap to the moon. So just kind of thinking back over, it's been less than 100 years really since we started even launching things into space. And I just want to take a look at kind of how far we've come, how far we've gone, so to speak. So if I can find the moon ever so gracefully, probably not, we'll go ahead and take a look at just our site for the first moon landing. Yeah, super graceful. So moon is it's our nearest neighbor in space. It's the most glorious thing to see in a telescope, but it's right in our own backyard, right? So about 240,000 miles away. It takes light just 1.5 seconds to get there. So even if you're trying to communicate with someone on the moon, it takes some doing. You don't have like instantaneous connection. Like if you've ever been sitting in a room talking on a cell phone to someone who's sitting right next to you and there's like this time delay, there's even more of a delay trying to talk to someone on the moon. So with the magic of OpenSpace, just kidding, it's not magic, kids, it's science. With the science of OpenSpace, we can kind of remove the shading of the moon. So even though part of this would be nighttime right now, because we're set for now, with OpenSpace we can just illuminate the whole moon. So just a few words about OpenSpace. Again, this is open source software, so you can download it, do what you will with it. Helps to have a pretty solid graphics card to run it on whatever machine. So if you have like a gaming computer, that should be sufficient. And then we have all this real data loaded into it. So a lot of it's from the Digital Universe Atlas that is primarily curated at the American Museum of Natural History in New York City. But we have data sets from NASA, from the European Space Agency, from all kinds of missions around the solar system, and surveys from different telescopes and research group, so we can dump it all into here and visualize it. And it's like, you know, you get to play around the universe in 3 dimensions, which is pretty exciting. So just kind of coming in here, I practiced. Not really. And this is kind of the region of the Apollo 11 moon landing. So some of the other, like 8 is a really famous one that went around the moon and recorded the Earthrise on, I think it was like Christmas Eve, the year before, 68, don't quote me on that. But 69, we came in, landed on the moon, we being people in general. Lost it. I think it's, oh, I had it earlier. It was kind of over here. But yeah, so just landed in this region. Oh, just kidding. More up here, like up in this area. The Sea of Tranquility. So just this big kind of, it looks flat from up here, but even up here, this is still not super high resolution. I'm not going to load in the super high resolution maps tonight because we're going other places. But the Maria are relatively flat, all right, but there's still just craters upon craters upon craters. It's also darker. It's more basaltic rock like we find on lava flows on Earth. But yeah, so a similar formation of those regions of the moon from ancient lava flows on the moon. So some of the other moon landings after 11, so 11 was in this nice flat area. 12 and 14, remember 13 didn't land. If you saw the Tom Hanks movie, you know all about that. Those were not as smooth, but not so bad. 15, my favorite, was way up by like on the other side of these mountains up here. Very, very cool. 16 was more in this bumpy region, and 17 was over kind of on the edge of a different Maria, the Sea of Serenity, kind of up in a little corner there. So footsteps on the moon, some giant leaps and then some small steps, but bigger steps than you could take on the Earth, right? With the low gravity, the astronauts could go bouncing around, and must have been a trip. There was even, I know someone will know this, one of the astronauts that brought a golf club, and it should have been like the longest golf drive in history because it was on the moon. But those suits were like really bulky, you know, because they had to have like a whole life support system on them because, you know, no air, no water, et cetera, climate control, everything had to fit in those suits. If you saw the more recent launch of Dragon with SpaceX, those suits are like super sleek. Plus, they weren't going to be doing like a spacewalk in that suit. Like they didn't have to like sit in it for, you know, hours and, you know, walk around the planet or go outside the ISS in those suits necessarily. So they didn't have like the big air tank and all this other stuff. So with all that stuff, it's actually, apparently, I haven't tried it myself, but I've heard stories and I've seen pictures. It looks pretty challenging to move around in. But that's the furthest that people have ever been. So that's just kind of like a little bit of perspective. We just turn on the orbits, so these lines representing the paths of the moon and then the planets as well around our solar system, and just kind of move away. Like again, that's how far we've gone. That's how far out into the rest of the universe people have physically been. So people, that's as far away as our footsteps are. So that was like, I guess, a giant leap. Not too bad, not too shabby. 1.5 light seconds away. Woohoo, humanity. So that's it. We're done. Just kidding. So so that's as far as people have been. But even, I guess, before we started sending, you know, people to the moon, we needed like good maps. And so we've been sending out robots through the 70s, the 80s, lots of robots. And last week we visited Mars, which is basically a planet that's inhabited by robots. So, you know, you complain that it's 2020 and you don't have your flying car. Well, it's probably the least of our worries now in 2020. But there are robots on Mars, like a whole bunch of them, circling Mars. There's orbiting Mars and roving around Mars and sitting on Mars. So it is. There's like a robot graveyard, and then there's a bunch that are still active. So that's pretty impressive. So we started sending out explorers in our stead. So even though we couldn't, visit all these places, because sending people is really hard and really dangerous, we do have, people living in space, but we've had our robots explore basically every planet and some non-planets in our solar system. So we've sent early on probes past Mercury, and so we got a map of all of half of Mercury, which is great. And then more recently, the Messenger mission to Mercury completed that map and just made it about 1,000 times better. So that was like super exciting for planetary scientists. Beautiful maps that we have now of Mercury, inner planet. We've sent probes to look at the sun. Parker, I think, is the closest thing that's ever traveled near the sun that we've sent out there. We've landed a few things on Venus, which is really, really tricky because it's kind of hellish. I think I can say that on YouTube. Um, it's horrid. Like you don't want to go there. And I don't think we've sent a whole lot back since. But Mars, we've sent plenty of things to. So we have orbiters, we have probes, we've had flybys. The largest canyon out on Mars, Valles Marineris, that we saw last week, that was named by for one of the Mariner probes that went zipping by it. That was the first thing to see it. So you can't see the Valles Marineris in telescopes from Earth. Even though it's like this huge gash, it doesn't have a lot of color contrast. So last time I showed some of the other features that do have more color contrast that we'd be able to see in telescopes on Earth. But the Valles Marineris doesn't actually show up. Not through the telescopes we had at the time. So moving out further, we have this big empty space. It's not open space. That's a different kind of open space. It's just empty space, we'll call it. But we do have asteroids in here. There's a body in here that used to be classified as a planet. So Ceres was first a planet, then it was an asteroid. Now it's still an asteroid, but it's also a dwarf planet. Good for that. And so we've sent robots to go and explore some of the asteroids and comets that we've talked about in here. Some of the other explorers we sent to the outer solar system, the earliest ones, Pioneers and Voyagers, and those are still going. So I wanted to spend a little bit of time looking at those. So Voyager 1 went out first, and these were early, just kidding, late 70s in 77. So there's not going through the whole time scale here, but you can see where it hits the different orbits. So there's Voyager 1 out to Jupiter, Saturn, and then beyond. Beyond. So Voyager 1, that was the fast one. So it was launched first, and then it only went to Jupiter and Saturn, and then it went shooting up. We're gonna call north up. So this would be the north side of the solar system. It went shooting up out of the plane of the solar system. Voyager 2 launched a little bit later. We'll scroll out a little further. Oh, there's Pluto. So Voyager 2 went out to Jupiter and Saturn. So you can see its little lines in there. So Jupiter and Saturn. And you can see that it did. It arrived, at Jupiter and Saturn later because it was launched a little bit later, just a few months after Voyager 1. And then out to, other one, Saturn to Uranus, and then Uranus to Neptune, and then beyond. So the Pioneers have gone out. Those are much slower, but they didn't visit the outer solar system. So for a long time, Voyager 2 was the only thing that we'd sent to the outer solar system. So all the really nice pictures of Uranus and Neptune came from that one mission, just a flyby, until Well, until New Horizons. So New Horizons went out. It missed those planets because there's a lot of empty space out there. But it's actually been out beyond those orbits, you know, out past Pluto's orbit and beyond, and it's still going, still kicking it. But the Voyagers are the most distant objects that we've sent out beyond our solar system. So these are, not sure the dates. It just says to infinity. But if we set it for today's date, that should be more or less where it's headed out now. So you can kind of, I don't know if you can kind of see still the little green dot of Pluto. So New Horizons it's well past Pluto, but not by a whole lot. It's out at 47 astronomical units. So an astronomical unit, that's the average distance between the Earth and the Sun, which you can barely even see at this point, right? So there's, you know, the Sun is somewhere in there, and I promise the Earth is still there too. If you can see like a really tiny blue line in there, right? So we're mostly just seeing the outer planets here. But so 47, it's at 47 astronomical units. That's New Horizons. But then the Voyagers are almost 3 times that far. So Voyager 2, the second one that went out, the one that went to all the outer planets and then shot, we'll call that down. So Voyager 2, that's at 123, 124 AU. And then Voyager 1 is the most distant out there. It's at just about 150 astronomical units. So at that distance, they've left the solar system in one sense. So some people might define the solar system as being, you know, beyond the orbit of Neptune, or beyond the orbit of Pluto, or beyond the Kuiper Belt, or, you know, so part of the exciting part of sending these out there, and in 2 different directions, you know, kind of upish and downish, we're getting a sense of where is the edge of the solar system. Is there an edge? How are we going to define it? And so kind of the definition that we've come up with for now is kind of the edge of where the sun's magnetic field intersects with and has an influence versus the interstellar medium. So there's all kinds of ions flying around out there, radiation from other stars and things. But the sun's magnetic field shields us from a lot of that. So this heliosphere, we'll call it, that's kind of the sphere of influence, this magnetic sphere of influence of the sun. We're gonna use that as kind of the edge of the solar system. So both Voyagers have left that region and are now out just in interstellar space. So it takes a while to get a signal back from them. Don't remember, didn't write that one down, but a long time, many hours. I think it's still less than a day, but more than a day for a round trip to get a signal out and back again. So they're way out there, right? But they're still like not even close to, if you want to say the Oort cloud is the edge of the solar system, then yeah, we're not even close. So the Oort cloud would be out much further. So that region where a lot of long period comets such as Neowise spend the vast majority of their time. They're basically halfway to the next star system. So if we move way out here, we can't even see, like, all that just shrinks away. We can't even see the extent of what we've sent out physically into the rest of the universe. So I just want to turn on the constellation lines so we can kind of see a little bit of reference there. Actually, we'll pause that. Constellations. There we go. So some constellations for us. Yeah, so eventually we would get to the other stars. But there is one other thing that we have sent out about 80 years ago. We started sending out radio signals. So we actually started sending out light. So if you look, you know, from one of these other stars, one of the nearest stars to us, if you look with a really strong telescope, like any telescope that we have on Earth today, probably wouldn't quite show us the Earth. If we were far far away, like we wouldn't really see the Earth. It's too small. It's too close to our sun. Um, but we're not like just reflecting light, but we're giving off these radio signals like that we use to see if I can find us. Whoosh! There we go. Um, since about 1939, 1940, we've been projecting radio signals for radio and television that are strong enough to leave our ionosphere. So one of the great things about Earth's ionosphere, which is part of the atmosphere, is that it reflects these signals, which means that your signals can go really far. So you can go up at an angle and then bounce off the atmosphere, the ionosphere, and come back down to Earth. But some of those signals actually escape and they're expanding out to space, so they're ridiculously weak, probably undetectable, certainly undetectable by any technology that we have if we were that far away. But it's kind of neat to think that, yeah, we've managed to eke something out. We've leaked out a little bit of information, hey, we're here. And if anybody actually picks up one of the probes from the Voyagers, there's a map. Like, we sent out a map of like, hey, this is exactly where we are. Come find us, which, I don't know, someone was asking me if that was a good idea, and I'm not sure. So someone obviously thought it was a good idea, so well, it's out there. But there's also this ridiculously weak signal that's out here, about 80 light years. If it's been traveling at the speed of light for 80 years, these are all the stars that it's washed over. So stars out here haven't heard from us, so even if they're listening really, really hard, they probably don't know that we exist, which is probably okay. But everything in here, our radio signals are very, very ridiculously faint, super weak because it spreads out and gets weaker and weaker as it gets further away. But they've washed over all these stars in here, which is a lot. There's a lot of stars, so 80, rounded up to 100-ish, because astronomers like their orders of magnitude. So there's a lot of stars within 80 to 100 light years from Earth, like a lot, like all of these that we're seeing, plus a bunch of dwarfs that I'm not even bothered turning on, but but they're out there. So the exciting thing though then, and the reason that I had you look at that one little patch of sky between Deneb and Vega is because there's other stuff besides stars out in the galaxy. We have these other things called exoplanets. And a whole bunch of the exoplanets we found in that region of the sky that's kind of between Deneb and Vega. And mainly we found a whole bunch there because, well, we were looking there. So we can find that same patch of sky. Oh, yep, there it is. That's what we're going to call the Kepler field. So the Kepler Space Telescope was up in space. It was staring at this spot continuously for 4 years. 4 years. And its job was to find planets, other worlds around other, hopefully, sun-like stars. So a lot of them are sun-like, some of them are not. But it was quite successful. It found several thousand, and we've since been confirming those. So to date, there's about 4,100, almost 4,200 confirmed exoplanets. So that was just looking at one spot in the sky. And the idea is that if we looked anywhere else, we'd see the same thing. So you can see some of the yellow dots on the other side kind of penciling out. But this is just one survey. So if we looked in any other direction, we would expect to see the same density of exoplanets, of planets orbiting other stars. So we haven't looked everywhere yet, but everywhere that we look, we see lots and lots of exoplanets. So all these little blue circles are not exoplanets, but they are stars with exoplanets. Because just like our star, the sun, has multiple planets around it, a lot of the other star systems that we found have multiple planets around them. So we haven't been out here, but we've looked out here. I wasn't going to go and say, oh, we've looked all the way to the edge of the universe or something. But it's kind of exciting to kind of combine our sphere of teeny tiny itty bitty super weak influence with the exoplanets. So if we pop back inside of our little radiosphere here, our 80 light year radius radiosphere, and we see not just the stars, but the stars that have planets. Um, and that's just kind of interesting and maybe scary to think about, depending on what you think potential life on other planets might be. So we haven't found life anywhere. That's, why we're sending Mars 2020 out. So remember, launch date is next Thursday, bright and early if you're on the East Coast. Dark and early if you're on the West Coast. So I believe it's scheduled for 7:30 a.m. Eastern Standard Time. It'll be 4:30 a.m. Pacific. But something to look out for. See if we can find life in our own solar system or evidence of past life in our own solar system, besides what we have on just this one little planet that we all live on. And then just kind of imagine what else might be out there that we may or may not encounter, something that may or may not have encountered our signals. But I'm just going to leave you with that. So back to credits, roll credits. I just want to thank everyone for joining as usual. Again, I'm Irene Pease with the Amateur Astronomers Association of New York. And if you enjoyed this, or if you want to learn more about astrophotography or take a class or join some of our special interest groups, you can sign up. AAA.org website, and you can follow us on all the social media things at AAA.org. And again, just the programs that we've been using for visualization tonight: OpenSpace at openspaceproject.com and Stellarium, which you can find at stellarium.org. So thank you again for joining us for your Thursday evening dose of astronomy. One last thing, I made a huge note and I almost forgot. Next week, we might not be on YouTube, but we will be on Facebook. So we're changing up some of our social media things. Same handle, same bat time, but a different bat place. So we'll be posting on our social media channels. Tune in on Facebook. If we can, we'll stream on YouTube as well. But if you don't see anything on YouTube, go to our Facebook page and we'll post links and stuff on our main page as always for that. So hopefully I'll see you again next week on Facebook. Possibly not YouTube, but thanks again for joining, and have a good night. Be safe out there.